And hello again, everyone. Welcome back to yet another demo video for HLIFX 002, yet another application of this board. Getting a lot of work out of this board. It's certainly becoming the workhorse of HLIFX, partly by design, also in part because at the moment we're dealing with a lot of chip shortages and supply problems. It's making it really difficult to come up with new boards and new designs. We are working on that. We're doing research and development. We're developing concepts and things like that. But right now, our biggest choke is actual production, actually making boards, getting the parts to make boards. We are scratching and clawing to get parts just like everybody else. We're not quite at the fight to the death situation yet, but I would not be surprised if at some point in the future it might actually come to that. Jokingly, of course. But yeah, it's really hard getting parts and getting supplies. We're doing the best we can, but in either case, we are coming out with a new design for a new setup for 002. And this one is something I've been working on in the background for a little while. Sort of a little pet project of my own. And I came up with this idea for a lot of people who build dioramas, vignettes, scenes, as I sometimes like to call it, and various kinds of atmospherics. That's sort of the intention of this particular board. And this is the R.A.L.F board. That is reactors, aliens, lights, and fire. R.A.L.F, or R.A.L.F for short. Not the name R.A.L.F, R-A-L-P-H, but the word, the acronym R.A.L.F, R.A.L.F. Now, the actual order of the modes on this board is fire, lights, aliens, and reactors, or FLAR. And I was originally going to call it the FLAR, or the Flarkin board, for those of you that might get the reference. But I then came to the realization that if you spell it backwards, R-A-L-F, R.A.L.F just sort of rolls off the tongue a little bit better than FLAR or Flarkin does. And the other powers that be at HLI said, you know what? Yeah, let's go ahead and call it the R.A.L.F board. So this will produce one of four modes, one of four sets of effects: fire, glitching lights, a slow pulse/fading effect for like aliens, monsters, horror sorts of things, and reactors, which is a much faster, more intense pulsing effect. Again, for things like power sources, energy sources, and what have you. So again, it's mainly meant for atmospherics, but I think there's a lot of potential in this board over a lot of different genres and applications and kits and what have you. So before I get into the demo portion, I just want to do a quick overview of the board once again. I've done this in just about every demo, but it doesn't hurt to do it to remind folks out there. As you can see, the board itself here on my cutting mat is about 1 inch tall and about 2/3 of an inch wide. We do try to make the boards as small as possible without sacrificing reliability. All the components are on the top side of the board. You're actually looking at the underside at the moment. You can see that we have HobbyLink International, HLIFX 002. We've got our 5 primary control pins, A, B, and C, D, and E. A, B, and C are the lighting channels. That's where the effects are actually produced. D and E, depending on whether or not you connect them to ground or leave them alone, will select between the 4 different modes possible. We have also VN, ground, and 5 volts. These are your power pins. VN is your positive voltage in, so that can be plus 9 volts or plus 12 volts. The board is tolerant for both. We do optimize the boards for 9 volt use. We do recommend that. A lot of folks like to drive their circuits at 9 volts. Circuits do run a lot more efficiently. They generate less heat. They consume a lot less power at 9 volts versus 12, particularly for LED lighting and LED strip tape. Ground is your negative power connection. That's the negative wire of your power line or the ground of your circuit, however you want to think about it. Plus 5 volts is a 5 volt constant output pin. It's not used for the R.A.L.F board. It's just a placeholder for other designs that we're working on in the future. But you don't use it for this setup, so you can leave it disconnected and not worry about it. We do put all our labeling on the underside of the board to save space and make the boards as small as we can. Also, we can make the lettering bigger and more easy to see. And I do personally recommend that you run your wire, your hookup wire, through from the top down here to the bottom side and solder at these points. It's just a little easier on the board that way thermally in terms of stress and whatnot. It's less likely that you'll damage a component with your soldering iron by accident. And you trim off the excess bit of wire, and just a little dollop of hot glue or some kind of thick adhesive that you trust can then attach the board to wherever you need it. We do recommend at HLI you put your boards in your bases. It's just easier that way. If something goes wrong or something needs to be troubleshooted, you don't have to cut open or break open your model if you have easy access to the board. But that's just an overview of the FX002 board itself. Like I said, all the components are on the underside, but I'm not going to bother show that to you. You'll see it well enough if you actually go and buy one of these boards yourself. But that's the overview. What I'm going to do now is switch over to the breadboard demo portion and show you what the effects look like. So I'll do that, and I'll be right back. And I'm back. I've now set up the demo portion of the R.A.L.F board. This is the breadboard that I use for a lot of my prototyping and design work for the HLIFX lighting and control boards. It's easy to do things on a breadboard sometimes, but what I've done is I've taken the 002 board, see here in the background hopefully, and I have temporarily jumpered that over to the breadboard. Pay no mind to this LED, that's just letting me know that I'm actually getting power to the breadboard. I'm supplying 9-volt DC power, because again, the board is tolerant for both 9-volt and 12-volt power. We recommend 9 volts, that's why I'm using it. But it'll work just as fine on 12 volts as long as your resistors or your LEDs are resisted properly. But how this works is we have our 3 effects channels, A, B, and C. Right now I'm using yellow LEDs across all of them, just to, have some stand-ins for each channel. I just picked yellow, but you can use whatever colors and whatever sized LEDs you want. Red, yellow, green, blue, purple, ultraviolet, 3mm, 5mm surface mount LEDs, LED tape, as long as you keep the number of LEDs per channel under 12, so 12 or less here, 12 or less here, and 12 or less here. Wired in parallel, of course, again, with appropriate resistors. You could, again, use LED tape as long as you keep it under 12 segments per channel also. Channels D and E of the board, which I have connected through these toggle switches here, those will determine what mode of the board you're in, whether it's, again, fire, lights, aliens, or reactors. Now, normally what you would do is you would either leave pin D or E alone, that is disconnected, nothing soldered to it, or you would run a wire from pin D or E to a ground point in your circuit. So a wire connecting or soldered, say, from pin D to ground or pin E to ground, or both, again, depending on which mode you want to set. And I'll go over that here shortly. In my case, just for demo purposes, I'm using a toggle switch, which will allow me to disconnect the pin to ground and connect the pin to ground, so I can easily switch between the different modes and not have to juggle wires around in front of the camera. You can use toggle switches yourself if you want to be able to switch between different modes. For most folks who buy this board, it's more than likely you're just going to want it for one mode, so you're going to figure out in the instructions which pin goes to ground and which pin is left alone, and just set it up that way and leave it be, right? But if you really, really wanted to be able to select between the different modes, you can do it with toggle switches, and the instructions go into that a little bit. But again, for here, it's just for demo purposes, so I can easily switch between the modes. So mode 1 is leaving pin D and E disconnected, not shorted to ground. So, and that's how I have it set at the moment. So I'm going to apply power to the board. That puts us into mode 1, which is fire. And as you can see, we have 3 flickering LEDs. So this is to simulate, as I said, fire, certain kinds of thruster effects, if you're interested in doing that. Anything where you might want a flicker or some kind of indication of thrust or force, right? And so on and so forth. So I think of like dioramas, vignettes, scenes, as I sometimes like to call it, engines, sometimes power, but I really think of it as either fire or thrusters. And as you can see, these are not in sync with each other. They're desynced. They're all flickering on their own. This is actually a pseudo-random effect, meaning if you were to study this for hours and hours and days and days and days and devoted your entire life and memory to it, you might be able to predict the patterning, but odds are none of us are going to do that. So to our eyes, it is random, but there is some patterning at work. That's the way pseudo-random is. But as you can see, we have 3 flickering effects. So this is, again, is good for fire. Like where I am going to probably be using this is whenever I get around to building my big 1/44th scale Godzilla kit. Having some fires scattered around on the base, which is a ruined cityscape. I have a Vermithrax dragon kit from Pegasus. I've seen people put fire effects in the base on that. I think that might be a place where I use it as well. I thought about using this for engine thrusters also. I like my thrusters to actually be synced, to have them all flickering the same way. And you can do that here because you can have multiple LEDs per channel. So I could theoretically only use one channel and connect a bunch of LEDs and have everything synced to that particular effect there. So, but the point is you can have 12 LEDs per channel, or so to say 12 LEDs for this particular effect, 12 LEDs for this, and 12 LEDs for this. So you can spread the effect around wherever you need it to go. Another thing you could theoretically do is, take an LED from channel A and B and physically put them, close together, right up against each other. And, if you put some diffusion around that, you could also mix those 2 effects together and get a slightly different looking effect. It'd be a little bit more constant, a bit more, bright, not as much flicker, but you get something a little different. You could mix and match LEDs from different channels that way, just putting them close together and diffusing them to get different mixings. But again, just a basic flickering, flame, fire, candle, thruster effect. Nothing too fantastical. It's a pretty standard thing you see in a lot of models and dioramas these days. But you get 3 different ones across 3 different channels. So now I'm going to switch into mode 2, which is lights. Now, if you are going to want to be able to select between different modes using switches like this, one thing to understand is that you have to turn the board off, then make your selection, then repower the board. The board goes into a particular mode on startup. After startup, it stays in that mode. So you have to make your changes and then repower the board. That's just the way we have it set up. There are a number of reasons why we do this. It, in terms of optimization, speed, memory, and various other things. But in this case, for mode 1, which is lights, glitching lights, we take pin D and we jumper that to ground. We connect it to ground. So that would be like taking a wire, soldering it to pin D, and connecting it to ground. So in this case, pin D is now connected to ground, and pin E is still disconnected. If I turn the power back on, and here we have malfunctioning lights. Now there's a little bit more repeatability, there's a little bit more patterning to this because that's the way I think it should be with malfunctioning lighting and power. But as you can see, hopefully even here on the camera with my bright lighting above me, the LEDs are effectively glitching. A lot of time the LEDs are at full power, but every now and then they shift down to a low power state, so that would sort of be your malfunction, and then every now and then they just wink out for a short period and then come back. They could either come back to full power or full brightness, or they could come back to intermediate. They could jump around. The amount of time spent in each state is pseudo-random, and which state they jump into, high power, low power, off, from one to another is also pseudo-random. So again, a little bit of patterning, maybe for the first 15-20 seconds. You might notice some repetition every time you turn the board on, but you let it run long enough, even 30 seconds to a minute, and you'll probably lose track of what states go into what. And again, that's the whole point, right? Is some predictability, but not enough for you to really keep track of. That's how I think of it when I think of malfunctioning lights and malfunctioning power. But yeah, that's it. So this was actually one of the harder modes to get to look right, because there's a lot of things you have to consider. How long do you spend in dim? How long do you spend bright? How long do you spend off? Do you spend more time off versus dim? How often do you jump from bright to off, or bright to dim, dim to bright, dim to off, so on and so forth? A lot more math and a lot more random calls than you might initially realize. So this one took a little bit more to think about, but I think it's at the point where I think it looks pretty good. So, where might you use this? You could think about, say, again, malfunctioning lights, like an apocalyptic destroyed cityscape. Maybe somebody running a generator, and you're running out of gas, and power's starting to fail. I actually plan at some point, probably in the far future, putting this into a battle-damaged USS Constellation, having deck lighting, most of the deck lighting off, some of it on, and then some of it malfunctioning, right? To give the appearance that there is power in the ship, but things are kind of off because it's mostly destroyed. I could easily put this in my Godzilla base as well, because again, there are destroyed buildings. Lots of different options here. Again, you could theoretically, take LEDs from different channels, put them up close to each other and mix. I don't think that serves as well in this mode, but it is a possibility if you really, really wanted to do that. But that's malfunctioning lights. I think it looks good. I think it really does help capture the essence of how flickering and failing, especially like fluorescence, would look. So, yeah, that's mode number 2. Lights. We're now going to switch to mode number 3. So for that, pin D is disconnected, and pin E is connected to ground. So pin E is now jumpered to ground, pin D is disconnected. Mode 3, which is aliens. This is a set of very slow, very lethargic, what I like to call frustrated fading. Very slow, 95% deliberate, repeated, patterned, but there's just a little bit of randomness to it. Now, how this works is every period, that is the amount of time fading up and fading back down, that's what I'm calling one period. Every time a period is finished, the next period will be ever so slightly longer or ever so slightly shorter. So, and that amount of variation is random, not by much, just by a little bit. And what that does is it causes these lights to slowly go out of sync with each other. And you can see that as time goes on, sometimes 2 of these channels sync with each other, then they get out of sync. Sometimes all 3 will sync into each other and then go out of sync. So by slightly varying the times against each other, the pulses, the fades, go into and out of sync with each other. So again, it introduces that little bit of randomness to the effect. And it's designed to be very, very slow, very deliberate, very, I guess the right word I like to think of is lethargic. So imagine, a 1950s, early 1960s film. You've got the theremin music playing in the background, and the monster comes out of its hole, or the swamp, or its cave, or the aliens emerge from their spacecraft. It's that sort of monster slash horror slash aliens kind of thing. That's why I call it the aliens mode. Like I said, very slow, very deliberate. Now, there is one thing about this mode that does have a little bit of a drawback. In the interest of full disclosure, because I am more than willing to talk about the strengths and weaknesses of every board we make. Every board has strengths and weaknesses. Anybody that tells you otherwise is deceiving you. Um, in this particular mode, because the fade is so slow and deliberate, there is a possibility that under the right conditions, as the LED gets to its minimum brightness, that is just as it cuts out, or just as it starts to turn back on, you might notice just a wee little bit of what some people might call flutter. It's actually stair-stepping up in brightness. And this is the most apparent when the LED is at its absolute dimmest. You can't actually see this on camera because the camera has a different refresh rate than my eyes. And it's actually smoothing that out just a little bit to the point where you can't see it. And in all honesty, diffusion takes care of 95, 98% of that. The reason why it happens is because of the control circuitry that we're using. It's 8-bit. That means there's 256 levels of brightness between absolute minimum and absolute maximum brightness. It may seem like a lot, but you'd be surprised at how sensitive the human eye is. And so if you have a very, very slow, very deliberate fade, at its absolute dimmest, sometimes you can see that stair-stepping up. All the way to very, very, very dimmest, like I said. But if you see that, don't worry. It's perfectly normal. There's nothing wrong with the board. It's just essentially the resolution limit of the chips that we're using. But as I said, some people might never see it. It's going to depend on the LEDs, your ambient lighting, how good your eyes are, how responsive your eyes are. And as I said, 95% of the time, a little bit of diffusion, a little bit of fiber fill or cotton or anything like that will typically smooth and smear that out enough to where you're not going to see it. And you're especially not going to see it on camera again because of the refresh rate. But that's really the only drawback of this mode is sometimes you might see it. Sometimes you might not. But that's Aliens. Pretty simple, straightforward, very slow, deliberate, ramping up and down. So, classic alien invasion, monster horror reveal. Again, I always think about that theremin music in the background. So that's mode 3. We come to the final mode now, which is mode 4. And this is actually my personal favorite, and that is Reactors. So now, both pins D and E are jumpered or connected to ground. That gives you mode 4. So with reactors, you think about pulsations, but faster, more intense, and each period is more random. That is, the length of each period can be fairly short or somewhat long. And if you stare at this long enough, you'll see that some periods are so short they come off more like flashes or pulse or very quick pulses, and some are rather slow. And what this does is it desyncs across each channel much faster. You see a lot of syncing and desyncing as you go. And I think it just produces a really, really cool looking effect. So again, sometimes all three will pulse together, then they'll get out of sync. Sometimes two will get in sync and stay there a little while, then very quickly come out of it. So think I can always imagine anything Irwin Allen, for instance. The C-View reactor, the Flying Sub, a very, very classic example. To some degree, the Jupiter 2, the Spindrift, all those pulsing lights. And again, you can use up to 12 LEDs per channel, whatever sizes and colors you want on each channel, as long as they're resisted properly. So think about all different manners of colors flashing off together. I just think that would produce a really cool looking effect for a reactor. Like I said, it's the reactors mode. One place where I'm definitely going to use this is in my 72nd scale German flying saucer. I can never pronounce the name correctly if it's Hanabu or Hanabu 2 or I always have a hard time with that one. But the squadron kit. I've seen people take for the main reactor and that big thick acrylic rod and bits of lucite and put pre-flashing LEDs in there. It looks really cool. I think this is a situation where this particular board, it would look really, really awesome. So that's the reactors mode. So that's all 4 modes of the board. Again, which one you select is going to depend on which pins D and E you connect to ground or not. So I'll go through each of them really quickly one more time. So D and E disconnected gives us fire or flickering thrusters. We connect pin D to ground. We go into glitching lights. We connect pin E to ground. We go into aliens / monster horror, slow fading. And if we jumper or connect both D and E to ground, we get reactors. So that is the 4 different modes of R.A.L.F, R-A-L-F. And there's one last thing I want to do. I didn't know if I was going to do it for this demo video or not, but I think I am going to do it. Another way to use this board that I'm probably actually going to employ myself. But let me set that up real quick and just show you a quick demonstration of it. It'll be more detailed in the instructions, but just let me go off for a couple minutes and set that up. Okay, so what I've done here, and I hope you can see this, it's a little bit more difficult to do because I'm using a clear LED here, but this is an RGB LED. If you don't know what that is, it's red, green, blue. That means there's a red, green, and blue diode all in the same package, and a common pin. Now, there's 2 different ways to do that: common pin positive and common pin negative. In this case, if you want to use an RGB LED for this, it needs to be common pin positive, also known as common anode, where your 3 color pins are your negative returns. The instructions will have a special section devoted on how to do this, how to wire up an RGB LED, because you have 3 colors, red, green, and blue, and you have 3 channels, A, B, and C, which is perfect. So you can actually mix these 3 channels together and get some interesting looking effects. Now, what I'm going to do here is take a little bit of some fiber fill and put it over the LED, over this LED, because RGB LEDs work better with diffusion, so that the colors mix more evenly. So I'm just going to pack this over it real quick. You can also hook up multiple RGB LEDs if you want, and mix and match the different color channels. Again, that's a bit more of an advanced thing, but it is possible. Again, the instructions will go into that a little bit more detail. But right now I have it set to fire. So let me go ahead and turn this on. and you get all manner of interesting looking flashing effects. Apologies for those of you who maybe are super sensitive. I probably should have put a seizure warning on this to begin with, but I didn't. Might also help if I put a piece of paper towel above it so you can actually see the reflecting colors a little bit. Kenny seems to think this looks a lot like welding. And of course, the camera is just having a field day trying to understand what's happening with all the colors and whatnot. But it's an interesting looking effect. So it's just an example of the color mixing. Let me switch to Malfunctioning Lights. So again, mode 1. This one I think looks a little bit more interesting. Maybe not necessarily that much application for it, but you can see all the different colors, and the auto contrast is just having a field day right now. But you got cyan, greens, magentas, occasional white. You're seeing a lot more of the mixing colors, the cyan, magentas, and yellow greens, than you are, the primary colors. And every now and then a little bit of some cool white showing through. Switch over to Aliens, which will give you a little bit of a slower mixing. This is something that people might find a little bit more interesting, maybe a little bit more useful, because things shift more slowly, things desync more deliberately. You might get more variation of color and less, you might work a bit more toward the pure colors and less toward the mixed colors. So that's a pretty good mode to use for an RGB LED. And then finally, we come to my favorite, which is Reactors. Like I said, the auto contrast is just having so much fun with this right now. But that's definitely what I'm going to be using when I put this into my German flying saucer. No doubt about it. I really, really like this. I think this is one of the best ways to use an RGB LED on this board. Maybe a little fast, but again, it's because you're mixing 3 different pulses together. You add 3 pulses together, you're basically going to get something 3 times faster. So it's fast, it's quick, but to me that means intense. So again, reactors, power sources. And there you go. That is how you can use an RGB LED with the R.A.L.F board. And in theory, you could hook up multiple RGB LEDs to get some subtly different looking effects. That's a bit more of an advanced thing. There's a lot more wiring involved, but it is possible. You could have up to 12 RGB LEDs, and you could flip the color channels. You could put red on channel A, blue on channel or G, or green on channel B, blue on channel C. For your other RGB LED, you could put red on channel C, blue on channel A, green on channel B, and you could swap colors versus pins. Again, it makes the wiring a bit more interesting, but it's doable. So you could have all kinds of potential for different color mixing happening. You could use bicolor LEDs if you wanted as well to mix across 2 channels. Like I said, there'll be a special section in the instructions that talk a little bit about how to do that if you feel so adventurous. But that is the R.A.L.F board. 4 different modes: reactors, aliens, lights, and fire. Lots of different possibilities, lots of different combinations, lots of potential in this board. And we're really excited to see what some people are capable of doing with it. So if you're interested in a board that produces effects like this, you might want to consider stopping by the HobbyLink International online shop at shop.hobbylinkinternational.com. If these boards aren't up for sale now, they should be very, very soon. We are making small batches at the moment because we are short on parts because of the chip shortage and supply chain issues. I know at this point, to some it may sound like a broken record, but it is a very big, serious problem. I don't want to sound too gloom and doom, but there may come a point where we have to stop production for a little while simply because we don't have parts. It doesn't mean we still won't be working on designs and prototypes and concepts, but we may have to stop actually making boards for a short bit. But that will give us an opportunity to come up with new designs, new setups, so that when parts do come back, we can hit the ground running. Um, you know, but enough about that. I will put an end to this demo video. So until the next one, as always, take care, stay safe, and happy modeling. Bye-bye, everybody.